Hello everyone and welcome to Limeneers lab. This is Val, and on today's video, the Indexer module. To be more precise, the four first variants of the Indexer module. As you can see, those two gloves are different, because one only has curl and splay, like this, and the other one also has curl and splay, but also has force feedback. So in today's video we're only gonna look at assembling the Indexer modules for the first four variants, that is variant C, only curl, variant CS, that is curl and splay, CF, only curl and force feedback, and CSF, which this is, with splay, curl and force feedback. The CC variant, which is multi-curl, which will track the motion of the first joint and then the second joint independently, is still untested, so I'm not gonna do a tutorial on it now, so I'll leave that for later. Aiko on the Discord server is going to make a tutorial about the CC variant soon, link in the description when that comes out. Alright, step 1, you're gonna need ProtoGlove. As you can see, Indexer is built on ProtoGlove, so that means you're gonna need to build a ProtoGlove. If you do monocurl variants, you don't need the first and the last Proto guide on each finger, but I did put them in so I could experiment. For example, on this one there's some buttons at the tip of the fingers and also contact pads to replace other buttons. So all links to ProtoGlove are also in the description. There's a documentation on how to build it. It's not hard, it just takes a bit of time. So step 1, you're gonna need potentiometers, RK097N, the little green pots. For the curl, you're gonna need to cut the shaft of the pot to just 3 or 4 millimeters at most. Since every variant use curl, you're gonna need to cut the pot. You might get away without doing that if you have really big hands, but chances are you're gonna need to cut them. So to do that, I've designed and printed a small jig. It's gonna be in the jig folder, in the hardware folder on the GitHub page. Just assemble like that. Put the pot in, and then slide it in like this, and then we're gonna go to cut the pot shaft. Alright, now in the workshop we're gonna put the pot in this jig into a vise. If you don't have a vise, you can clamp it down to the side of a table, though I do recommend you use a vise. It's much more convenient. This, you can clamp quite a bit on it. Then to cut the pot, I like to use a hacksaw blade with a bit of tape as a handle, so that you can orient the teeth towards the handle so that it cuts when you pull the saw, not when you push. You make a much straighter cut this way, though it takes a bit of time to get used to. You can also use a regular hacksaw if you want, but it's a little bit less precise. Alright, so now let's start cutting. Blade flat against the jig, then pull and cut. Alright, now that it's cut, we're gonna clean the face a little bit with a file, like this. You're gonna end up filing the plastic a little bit, but should be fine. Alright, now it's all clean. You could use a brush to clean the filings if you want. I like to use compressed air, works much better. Just take it out of the jig. It can be a little hard when the jig is still new. You can also do a little cleanup because there's gonna be a sharp edge right there. Clamp it lightly, don't go too far. Make sure it's completely turned one way and only push so that it doesn't turn. The other way it would turn. You don't want that because you're gonna put dynamic forces more than static and you can damage things faster. Right, now the slot. There you have it. Cut to length and cleaned. So one last point about cutting the potentiometer shaft to length. I suggest you don't use an angle grinder or a Dremel because you could build up some heat inside the potentiometer and melt the contacts inside. I know some people have had success cutting them with an angle grinder or a Dremel, but I still do not recommend doing this. Alright, now that we have our potentiometers at their right size, we're gonna need to wire them up. We do that now because it's not going to be accessible after. So I'm gonna show you two methods. So first we're gonna solder the potentiometer and also tell you why you should or why you shouldn't. And then we're gonna use 3D printed solderless crimpless connector that I've designed for those who don't have soldering iron and or who don't want to fry their pots. So first with the connector, so it's gonna be in ProtoGlove electronics folder. It's called potentiometer connector. It's quite small, can be a little hard to print, but it's really convenient if you don't want to solder your pots. You're gonna need your wires. I like to use ID cable, this kind of old hard drive connection that is not used anymore. the 40 pin variants, 80 pins, the wires get really thin and it's barely usable. So you can just cut the connectors and use the wires as you want. So that's what I like to use. So take 3 wires, spread them apart, put them in the connectors, don't even need to strip them. Alright, like this, so it pops out a little bit at the top, and then take your potentiometer. You want to have the wires going down like this, not on top, or it's gonna interfere with the mechanism, and then push really hard, but don't bend the pins. That's the only downside with this connection. It could bend the pins. You have a risk of doing that. I'm gonna try to do it with my small bench vise so it doesn't bend anything. Just like this. The electrical connection is done by the pins actually stabbing through the insulation and making contact with the wires inside. I suggest you strip the other end and test the connections. Should be 10 kilo-ohm from the 2 outer wires and some value in between with the center wire and the outside wires. Alright, now for soldering. There's a few tricks to do it properly. First, tin your wires. Then very quickly tin the pins on the potentiometer. Don't want to stay too long, otherwise you're gonna melt the contacts inside. Same as cutting the shaft to length. Alright, good. If you have too much stripped and tinned, you only need 3 millimeters at most. Cut the excess, otherwise it's gonna look wonky and could have some shorts. Right, now to solder it onto. I'll just make contact with the wire, contact with the iron, second at most. More than that and you risk frying potentiometer. Done! There you have it, wired, soldered on potentiometer. Alright, without transition, now that our potentiometers are wired up, we're gonna go ahead and build the first variant of Indexer, that is variant C, only monocurl, so the other splay pot that doesn't need to be cut, by the way, can be put aside. So first, we're gonna need the frame. On the frame, we're gonna clip on the splay pot placeholder, which replace this one, just clips on. Then you put your curl pot into pot link like this, washer, nut, tighten it. You can use some pliers for that. You can tighten it really good. Now slide pot link onto splay placeholder. It should be able to turn. Then you would put a drop of super glue at the end of the pot placeholder cap and then put in like this, and it would glue in the pot link so it can't go out. Next, now we're gonna prepare the next 4 parts. That is the lever, the link A, link B, and link anchor. So just like on ProtoGlove, there are holes that need to be rimmed at 2 millimeters. You can use a drill bit. I'm gonna use a screwdriver like I like to do. This time the holes are sized closer to their final size, so it takes less time. Again, you can use a drill bit, but it can end up a little bit oversized. I like to use a screwdriver so it's much closer to its final size. Alright, then again, we're gonna need 2 nails, 2 millimeters diameter, flathead nails. One of them we're gonna need to cut at 9 millimeters, and the other one 13 millimeters. That's from bottom side of the flathead. So for that, I like to cut them with side cutters. So measure 13, this, 1 done, then 9, 2 done. One of the things that I like to do with the nails so that they slip in just right without any effort is to file the underside right there. It can be a little bit oversized and not really flat. So for that, I use a drill, put the nail in the drill, only let it stick out by 3 millimeters just so that you can slip a file in there. I'm gonna use my good old trusty multi-tool and file like that. If you don't have a drill, it's fine. You can just clamp it in a vise and then file it all around. It's just gonna take a bit more time. You don't need to go really far. One other reason why you want to file the nail is so that the link can turn without the nail turning, otherwise it can slip out of its hole. So we're gonna connect link A to lever with the 9 millimeter nail. Push the nail through link A, needs to be free turning without the nail turning. Then onto lever, this. Perfect. And it should also lock straight. This shouldn't be able to go past this point so that it doesn't flip the other way. Then link B and link anchor. Take the 13 millimeter nail, push it through the first part of link anchor, then slip in link B, finally through the other side. This time again, link B should be able to freely rotate about 120 degrees, shouldn't have much friction. Then we're gonna put lever onto potentiometer, so turn it all the way until it counterclockwise, and then turn it just so that the line is vertical, this, and slot in, put in the pot. The slot aligned with the lever. It's a bit tight, but that's how it should be. Then the next step is to install the module onto the glove. So that is snap fit the frame into the base plate and snap fit the link anchor into the first snap point of the second phalanx protoguide of each finger, like this. Then to know at which point you should glue link A to link B, you're gonna need to put on the glove with the module attached to it. Then, with your fingers straight and the lever vertical, link A will be free-flowing, link anchor snap fit onto the second protoguide like this, and link B free-flowing also. Finger vertical, it's easier to put it flat on a table, and then you're gonna want to find the spot at which the link A and link B join the most perpendicularly, and then you just snap them in place. Once you know what spot you're gonna connect link A to link B, you can just drop a bit of super glue in there so that it never moves again. So that's about it for the C variant. Now we're gonna go on to the CS variant with splay. For that, we're gonna take out the splay potentiometer placeholder, and we are gonna replace it with the splay potentiometer. Slid in the wire from the front all the way back, slot in the potentiometer, and it should snap fit in place. Washer, nut, tighten, and reassemble. So this time you want to find the center position of the potentiometer. So go all the way one way, all the way the other, and you can see there's a middle position. It's basically the first time the slot is perpendicular to the axis of the module. Then with that position in mind, just slot potentiometer link perpendicular to the slot, push it in all the way down, and that's it. That's the CS variants. So about cable management, the C and CS variants use those two parts, which is the cable tie and the cable cover. So first the cable tie goes onto the pot aligned with the slot, then put in the wire, fold it over so that the curled pot wire doesn't dangle around. Then for the cable cover, you want to tuck the wires inside this slot and then snap fit here, like this. And that's your Indexer CS module, wired, cable managed, and fully assembled. Alright, now we're gonna jump straight to the CSF variant, as the CF variant is just the C variant plus the steps we're gonna do right now for the CS to make it a CSF. Alright, for that you're gonna need, well, first a CS variant or a C variant, depending on what you're doing. You're also gonna need a 9G servo. You're gonna need to 3D print the force feedback frame. So this is just one part that will hold the servo, clip it on the module, the small arm that comes with the servo, the screw that comes with it. Also, fishing line, 0.8 millimeter should be the biggest size you should take. Do with what you have, basically. First thing you want to do is put your servo in the 0 position. For that, you need to flash the firmware in your ESP32 and then plug the servo in the ESP32. Then on the open glove driver, click on the retract servo buttons in the options. I don't remember exactly. So once the servo is in the 0 position, we're ready to assemble the force feedback module. So first, we need to cut the lever arm thing that comes with the servo. It is too long for our use. We only need the 3rd hole on the arm, so we can cut at the 4th and then chamfer the edges a little bit so that it doesn't interfere, like this. So that's it for the lever. We can directly screw it on the servo at this position, pointing direction where the wires comes out. Then we can put it onto the force feedback frame. So take your servo. The hole here should align with the screw once the servo is installed. This is the right way. If you install it like that, it doesn't fit. Alright, and that's about it. That's the force feedback module. Now on the CS module, to make it a CSF, we need to take out the cable management cover. You also need to take out the cable management tie because it's in the way. Alright, again here, tuck the wires in like this, take the force feedback module, slot in this like you would with the cable management cover. This is the same feature, that's what it was meant for, and press it in like this. So now you need to put a wire between here, this hole on the side of the lever, and the last hole on the servo arm. For that, you're gonna need a little length of fishing line, 15 centimeters. Give yourself a little bit of extra length so you can easily work with it. Otherwise, if it's too short, it can be a pain. Also gonna need to print the wire nuts. They are really small and on the lower end of what you can print with a 0.4mm nozzle, but it fits and it works, so I'm not gonna complain. Feed the wire through the first hole, this, then into the second. Don't go too far, barely any extra on the other side, then pull back. Then once the nut is installed, take out the super glue, put just a drop on each side to lock the wire in the nut. Alright, now that the first nut is installed on the wire, you can install the wire on the module. First from the top at the back, through the third hole, last one on the arm, like this, pull it through, then through to the front, but in the pot link there's a hole right there. You can access it from the other side, just need to land in it like this, pull it through, then through the hole on the side of the lever like this, pull it through. Now lever vertical like this, and we're gonna install the second nut as with the first one. Thread it through one side first, back through the other side, and this time we're gonna need to pull it tight, pull as much through as possible, then hold vertical and pull it through like this. So now if you pull on it, that's where it ends, so you need to pull a little more until when it's tight, it only goes like this, it can't go any further. Alright, good enough. Now another drop of super glue onto the nut. Be careful not to glue it to the lever, otherwise you're going to limit the motion of your finger. Let it dry, and now you can trim the excess wire, and like this. And this is it. This is your Indexer CSF module. Now you just have to snap fit the module onto your ProtoGlove. This video is part of the Indexer build guide on the GitHub wiki. It contains more detail about actually building the whole glove, goes more in depth into the firmware, wiring, basically all you need to make your own glove. But this is beyond the scope of this video, which was just to build the module. All the links are in the description. If you need help with your glove or want to participate, you can also join our Discord, Limeneers Labs. This is where we discuss on new ideas and new projects. By the way, big project soon. Thank you for watching this video, and big thanks to my supporters on Patreon, who really helps me make this project more viable. And I'll see you next time.